hard to tell sometimes because I don't hear the mic up here. I just hear me. So I can appreciate the input. All right, I lied. It wasn't graded last night. It was graded this morning. So you should have just received the email. I probably will not be able to upload those grades to Icon immediately. So I'll probably do that tonight at some point. I'll be traveling for the rest of the day, so I've asked the TAs to watch out for the Piazza bulletin board, so because I won't have access until late tonight, which is probably too late to answer the questions that are probably there. When I went to bed last night, I made sure I'd answered everything that was pending, and there's probably some new ones this morning, but it is what it is. Oh, come on. So homework 2 is due by midnight tonight. You have 24 hours to hand it in after tonight if you want to. The only thing is that your credit will be capped at 75%. This does not mean that you get 75% of the credit you earned. It means that at most you can score 75% of the points. It'll be graded like every other one, but at most 75% of the points. Sometimes students think automatically they see as 75%, that's a 25% of your points get lost, and that's not the case. Not everybody scores 100% on this thing. If you think you can get from a 30% to a 75% overnight by working on an extra day, it's in your interest to do that and just turn it in by Thursday at midnight. Sorry, let me just try a different. Put it in a different USB port. Let's see if that. Oh, look at that. Okay, midterm 3 takes place on Friday in class. The subject of midterm 3 is just object-oriented coding. People wanted to know what they should look at. There's a chapter assigned. We've gone over the Boggle implementation, which is object-oriented, and you just had a lab on object-oriented coding. Was that hard? Was the lab hard? How many thought the lab was like normal labs? How many thought it was easier? Anybody think it was harder? Okay, so that's because it's just an unusual way of thinking, right? So I thought one thing we should do today is spend a little bit of time on the Lab 10 solution, just so you can see how this thing is configured and everybody leaves feeling pretty good about what they did in lab. And those of you who have SDS accommodations, I believe I've added you all to the proctoring service website, so you know what to do. You sign up there and then go take the exam there. So I won't be here Friday morning. The TAs will run the exam, and I'll be back on Monday. Okay, so this is kind of silly object-oriented exercise about a coffee shop called Zip Drip that has clients and has a frequent drinkers kind of discount thing. And the only really fancy thing is that there's this thing called a perk, which is the discount percentage, which for now is all fixed, right? So the discount percentage is fixed in the class. And there's also this minimum number of cups that you have to have purchased before you qualify for your discount. Sort of straightforward kind of idea. So after you buy your first, so for every instance of class Zip Drip, which you can think of as representing a Zip Drip franchise, when it's created, they decide what their discount is and how many cups it takes to be called a good customer. So the default is that you get a 10% discount if you're a good customer, and you need to have had at least 4 cups before you qualify. So from your 5th cup on, you're going to get this 10% discount every time. That's actually kind of simplifying things because the discount is not applied straight to the cost of your cup, but we'll get to that in a minute. The discount is applied in a funny way. So this is the class definition. We know that we have this constructor method that takes the command line arguments that go in when you invoke the Zip Drip class, when you create an instance of Zip Drip. The default is a 10% perk and 4 cups minimum. And the only the only slot in here, the only variable in here is this client's variable, which is initialized to the empty dictionary. Now the idea behind this franchise is, as my customers come in and buy their coffee and they give me their phone numbers, I'm going to make an entry in my roster with the index being, the key being their phone number, and the value being a data structure that contains information about that particular client. Okay, so when I invoke Zip Drip, which is the class constructor, the name of the class, with no arguments. I could have given it a perk, or if I wanted a different kind of franchise, I could have changed these values, but I didn't. So I got the Z as a standard zip drip franchise that has a 10% perk after 4 cups. And if I look, I type in the tuple asking what the perk is, what the M cups are, and what the clients are, I'll see that the perk is 10, there are 4 cups minimum, and there are no clients so far. Everybody clear on that? So this is just the setup of the class, and it's good practice. It's not enforced, but it's good practice if you have variables, that's this perk, M cups, and clients, associated with the instance. It's good to initialize them in the initializer, right? So this is the init method, which is by default called whenever you construct an instance of the class. So here's the class constructor. It returns a new object, which is an instance of class ZipDrip. And this new object will be the self in running the initialization method. So for my three variables, I've decided to initialize them all to values here. If I wanted to give different perk and M cups value, I would have done it right here on the command line. I would have said 15, 10 if I wanted 15 cups. Or M cups equal 10 and leave the perk to default. Any questions here? Are you guys comfortable with this? Okay. There was a method associated with the ZipDrip class, which we called register. Actually, probably a bad name for it, but it's fine. It sort of gives the idea. And it takes one variable, one attribute, it takes one field, one value when you invoke it. And that's the phone number of the client. And what this method does is it looks in this object's client list for this phone number index. It's a key in the dictionary. If it's there, it simply returns the value of that client, which is going to be the record containing client information. If it's not in the dictionary, it's going to add it and create the new record. So let's see how this works. So it's really quite straightforward. This is a method of class ZipDrip, so it actually sits inside here, just under an it. It sits in here. The method says, if phone is not in my clients list, then add it and give it this value, which is a new dictionary of 0 drips, where 0 is the number of cups that you've bought, total 0, where total sums the amount of money you spend, and perks is an empty list. And we're going to use perks in just the way you used the windows and manage windows. We're going to use it as a sliding window. We're going to keep the last 4 purchases in this list in order. And as we add new purchases, we're going to take the oldest purchases off the list. That way we have the costs of the last 4 purchases in this perks list, so I can do some math and figure out what the discount should be. Because remember, the discount's calculated on the last 4, M cups equal 4, the last 4 purchases. And then when I'm done, I just return this record. Now notice, if phone is already in self.clients because somebody's bought a cup of coffee before, then self.clients will have a structure that looks like this, but the numbers will have changed. And whatever, if it's not there, I create a new one. But if it is there, I just return the one that I have. This is just a little indexing function. If I try to register this guy, this is a new number, right? This is not something that I've had here before because the franchise just opened. And I see that I get back exactly my record. Questions? Is it this simple? Straightforward? Okay. The last method is the only kind of silly, difficult method. It actually executes a purchase of a cup of coffee. And what makes this complicated is not so much the bookkeeping. In general, methods do a lot of internal bookkeeping. One of their primary goals is to update internal variables of that object, right? So if I'm going to buy a cup of coffee, it's going to be this buy method that keeps track of how much I spent and what the discount was and so on, and keeps track of that in the object ZipDrip. Is that rain? I hope not. So here's what my method looks like. So the first thing I do is I fetch the record by invoking the register method. Now this is a method we just saw, and what does this thing return? Well, this thing returns the record for the client at that phone number. And because this is a dictionary and is mutable, any changes I make to this record will be retained in the ZipDrip client's list, or ZipDrip client's dictionary, right? Because I'm modifying the structure, those modifications remain. So the bookkeeping is pretty easy. I add 1 to the number of coffees I've bought. I add the cost of the coffee, which is a variable value here. I add the cost to my total costs. And then I engage in the discount calculation and the perk stuff. So the first thing I do is I append the cost, the list price, say, of the coffee to my perks list. So I add it to the end of the perks list. Remember, perks is actually a part of the record. It had drips, totals, and perks. So I append the cost. And then I check, have I bought more than the 4 cups of coffee I need to qualify for a discount? If I haven't purchased 4 cups of coffee yet, none of this happens, and I simply return the cost because you don't get a discount, so you're going to pay full price. If I've bought more than 4 cups, so on the 5th cup, I'm going to recalculate the cost. The cost is going to be what it was minus this calculation, which we can't see. So let me see if I have the PDF of the solution. Oh, that's not it. That's the homework. I don't want to show you that. Where is my... There we go. Okay, sorry about that. These long lines sometimes get to be a pain on the slides. So I get the record, I update drips and total, I append the current cost of the perks list. If it's equal to M cups plus 1, or actually greater than M cups, yeah, this is an old version. Here we use the length of the records rather than the drips, but it's the same idea. And I subtract the value of the perk, which is the 10%, remember it's the initial value of the percentage, times the sum of the first 4, just the first 4 elements of perks, because I've appended the new cost, so I don't want to include that. I want to include the previous 4. I'm going to integer divide by the number of cups, which gives me that nice dollars and cents kind of description, and then divide that by 100 to get it in cents. So this integer divide of this discount will give me cents, divided by 100 will give me dollars and cents as a float, and I'll subtract that from the cost. And then I'll take the very first element of the perks list, because I've appended the new cost at the end. I'm going to take the first element of the perks list, I'm going to get rid of it. So I'm going to add my coffee cup, my cost to the end of the list, and I'm going to pop the other ones off the beginning. This should give you a hint for homework 2, right? We do something very similar to this in managing that queue. And then I return the cost, but of course the cost has now been updated. Now a couple of things going on here. First of all, the cost I return is either the discounted cost if I've bought enough cups of coffee, or the original cost if I haven't yet made the discount criteria. So whatever it is, I return the cost. And the second thing to notice is that in the perks list, I keep the list price of the cost rather than the discounted price. So your discount in the future will be computed on the list prices of the coffees you bought, not on the discounted price. So you will only be computing discounts on real values. Questions here? There are a lot of approaches here. I rethought this. This mechanism here, this says if the number of perks is 1 more than the number of cups. Well, here's the last cost I added. So if I'm on the 5th one, then I'm going to compute the discount, and then I'm going to remove that first one. This is a perfectly reasonable way of determining the discount criteria. A simpler one is just to check if the number of drips you buy is more than M cups, and if it is, you apply the discount in perpetuity. Now, I feel a little bit guilty about this total where I keep track of the actual list price. I was going to add a method that used total, but I thought it would be too much for the hour that you had, hour and 15 that you had in lab. So I got rid of it. So this total thing, which you're maintaining here, never actually gets used. I probably should have dropped it, but I neglected to do that. What I had in mind was to be able to compute the ratio of discounted costs versus total cost at any point in the client's status. So you find out that I ordered $150 worth of coffee, but I've only really spent $137.42. That was the kind of thing I was after. There wasn't time to do it in lab, so I got rid of it. But that explains the total thing. Are there questions on this? This is the most complicated method from yesterday. Did people get this? Some of you feel pretty good about it? Okay. So if I execute a buy on this number, this is a new number, and I'm going to buy $3 cups of coffees 5 times, and I'm going to collect the price because I returned a discounted cost, you'll see that the first 4 cups cost me $3, but then the 5th cup cost me $2.70, which is the behavior I wanted. Okay? There's a note here. Registration is automatic and silent. When I invoked buy on this number, this is a brand new number. It's like a customer walking in the door and saying, here's my phone number, give me 5 cups of coffee. The fact that I use this register method from within the buy method, remember register, if the phone number is not in the record, in the roster of clients, it's going to get added along with the new data structure. And that data structure obviously works because we're able to compute the record, the discounted cost of coffee. All right, so registration is silent and transparent. You don't need to go in and say, I want to register. You just buy a cup of coffee, give me your phone number, and it's all part of the sales process. Yeah, this is actually should say status up here. So this is, I apologize for seeming discombobulated here, but it's been an interesting time. Some of you know I'm leaving today because my daughter's wedding is on Saturday in Chicago. And last night we get a call about 8 o'clock from the emergency room. My daughter, who's a very smart, rational person, went for a bike ride in Chicago and fell off her bike and gashed her cheek. So she was in the ER for 12 hours yesterday getting a plastic surgeon to stitch her cheek up 3 days before her wedding. You can imagine this is not the one day you want to look good and you're like all swollen. It's not a happy time. So it's been a little bit stressful. Anyway, here we go. The status method takes the phone number. It's like if you go to the desk and say, hey, what's my discount status? What's your phone number? Type it in the system, and you get something that says, for this number, it says you still need 4 more cups to earn a discount. For this number, that should have been a paren, your next discount will be 22 cents. Notice that I can compute the next discount because the discount is based on the previous purchases, not on the value of the coffee I'm purchasing now. It's a cash off the top discount. So self and phone, the first thing I do is I get the record, again using that register interface to the client list, and I check to see if I'm at the number of cups, then your next discount will be, and I print out what exactly the same formula from before to tell you how many cents you get off your next cup. Otherwise, it tells you how many cups you still need before you earn your discount. Easy. All right? So that's the just, yes, in the back.
So how come you're using print statements? The spec says return it.
Oh, does it say return?
Yeah.
Because I didn't pay attention? Yeah. This should be a string you return. It should be like a string representation. My bad. I'll rerun it. Thank you. I messed up. Fortunately, I can fix it. You guys can't, but I get a second try at the autograder. Did I say return? I did. Yep, you're right. Yeah, and you can't tell here because it looks like a print, right? Looks like a print, looks like a return. Fair enough. All right. Well, that's it. Any other questions? All right. So on Friday, you can expect something very much like this oh, come on. on Friday you can expect something very much in the style of this particular assignment, okay? All right, interactive Boggle. Now we started this on Wednesday. I want to finish it today because I want to do next, pretty much starting on Monday if we don't get to it today, I want to do a little bit of text processing. What I'd like to do is I'd like to take a novel like War and Peace and write some code to parse text and do things with that text, like find out who are the major characters, find out which characters interact, build a map of the interactions of the characters, extract stuff, structural stuff from the text. And there are a lot of really cool tools to do this available in Python, but we're going to do it by hand. We're going to do it by writing our own tools, because that's the whole point of this class. They'll be a little cruder, but at least you'll get the idea of how it's done. And as I said before, tkinter is something that's difficult to work with because stuff breaks from one version to the other. And the tkinter interface that I describe here was written 2 years ago, and it doesn't work very well in Python 3.9. I don't have time to debug it. It works well enough to understand the general gist of the user interface. So this part, the user interface part, is not something I will test you on. I just want you to get the general idea of how it works. And the way that this kind of works is this basic model, which is shared with almost every user interface, graphical user interface you use. By the way, GUI is graphical user interface. You probably knew that. When you're writing code for GUIs, what happens is you will pop up the window. You'll somehow initialize that window from the library, that GUI library that you're using, and then you'll put stuff in the window. Whether you're drawing something, whether you're printing something, doesn't matter. And once the window is prepared the way you want it to be, your code goes in what's called a busy wait loop. It just goes in an endless loop, just waiting. What's it waiting for? It's waiting for events that come from input devices. So every time you do this, it's a little bit like in the homework, you wait for those dining room events as you read through the file. Each one is an event. Here, the busy wait loop is waiting for a mouse click, or it's waiting for a keyboard input, a key of some sort, or it might be waiting for a camera input with a QR code or something. Whatever it's doing is sitting there waiting until it gets what it's expecting. Sometimes you have to be a little bit fancy. You have to have timeouts or some way of setting a timer, so if you don't get the input, you don't hang forever. Maybe it pops up a window and says, "Are you there?" Click yes to go on or click no to quit, that kind of thing. And you have to also have an understanding of what these inputs look like. For a mouse click, you generally get the fact that the mouse has been clicked, which button was clicked, and where the pointer was within the geometry of the window. In other words, in the scale of the window itself. So like I mentioned the other day, we're going to take the original solution for Boggle, we're going to import a bunch of libraries, and we're going to specialize the Boggle class with the Boggle TK class. So this class inherits everything from the Boggle class, and we can add new methods and values to this class. So we add one new variable, keep playing, which we initialize to true. And then we're going to add some methods to Boggle TK. And when I play a class of type Boggle TK, it will use this class's methods, not the ones from the original Boggle class. If there's a method of this class that is not defined within the class, it will inherit the missing method from its superior, which is the original Boggle class. So in a sense, you can think of this as here's an object. I want all of its behavior. Here's another object that it inherits from this object. Any specialized behavior that I attach to this inheriting object supersedes the behavior of the superior object. Any method of the superior object that doesn't have something shadowing it in the inheriting object, when I invoke it on the inheriting object, I'll use the superior object's method. So I inherit those methods from above. This is an old idea. It goes back to the 1980s when a language called Smalltalk was developed by Tektronix in Oregon. And this language became sort of the model for all the object-oriented languages we use today, which include various versions of Lisp, which have object-oriented elements to them, Smalltalk, obviously Java, C++, all these, and Python. They all inherit these same kinds of ideas from that original class. that original language, Smalltalk. So let's start implementing our interactive Boggle. We'll pop open a window. And then this window is a construct in the tkinter library. And it serves as a container for a bunch of little gadgets or widgets. Those widgets might be text boxes, buttons, input boxes, and so on. So we're going to fill our window with a canvas object that I can draw on. And then within that canvas object, I'm going to draw the game board using the canvas drawing mechanism. So the game board here is going to be 16 squares with the letters of the Boggle puzzle. Each of those squares has to be sensitive to mouse clicks, so I can spell out my word by clicking. And then I'm going to have the 4 extra buttons below it, so 20 buttons in all, where the 4 buttons below it are the ones that let me ask for a new game, let me quit this game, tell me how many words I found, and so on, the ones that we had as special characters before. All right, so there are 19 widgets provided in tkinter. We're going to choose a very small number of those. We really need buttons. And we have, as you can see from the slide, there's a lot of stuff you have to specify when you use a windowing system. There are these, when you start with the window, there are various ways to populate that window. And those various ways are used for different types of applications you may have seen. If you're building a window that shows a nice graph, for example, that you want to make active so you can click on it and move points around, that's a very different kind of interaction than our Boggle game is. Or than the Othello game that I write in other semesters might be, where there's 8 by 8 squares and you click on them. Those interactions are much more complicated. So there are different types of geometry managers which describe how the elements, the widgets that you pack in this window, how they get placed. Right? So there's one called packing, one called grid, one's called place. And what it does is it governs how the elements you add to the window, how they get sort of allotted to space inside the window. And you have to have this because the window can be resized, and you need to sort of actively replace those elements to respect the window size attributes. So if you make the window too big or too small, how does the window respond to those? How does the window place those widgets so that it's still operable? And finally, the widgets that we're interested in are active. We're going to use buttons because that's how we're going to sense mouse clicks. Okay, so here's our window. We associate the frame. Geometry Manager says duplicate, sorry. And at the end of the day, for the active buttons, we're going to associate a function, which is actually a method of our Boggle TK class, called the callback function. Now, every interaction with a GUI, like a button click, provides you, in the case of a button click, the X and Y coordinates of the button with respect to the window and which button was pressed. And these parameters get passed to this callback function. So when you write the windowing system, you're going to create a bunch of methods or callback functions, one for each type of interaction you expect. It's going to receive these parameters. That callback function is going to do something with the parameters. In our case, it's going to light up the button and make it a different color. And then it's going to go back to the busy wait loop. So the interaction is click, pass parameters to the callback function, execute the callback function, exit, and go back and wait for the next event. So every time an event happens, the system wakes up, does a little bit of processing appropriate to the event. That processing is the callback. And then it goes back to waiting for the next event. That's how this thing works in theory. All right, so we're going to replace the round method that we had in the original Boggle function. So this round, instead of doing all the textual stuff, is just going to manage the game through the window. So the first thing we do is we're going to create an object of type TK. That's going to be our window. I'm going to store the window inside my Boggle TK object. This round function creates the TK. It's actually inside the Boggle TK class. So self.window is an attribute of Boggle TK, my object of type Boggle TK. I'm going to do things to this window. So self is a Boggle TK object. Window is a TK object. So Boggle TK, title, this is a method of the TK object. I'm going to set the title to be Boggle. That changes the little title bar at the top. And I'm going to set the window size to whatever geometry I specified. And this is one of the things that's not working apparently in 3.9. The default window size was this before. I don't know what it is now. It's obviously different. So all of these objects, right, like this object of type TK, they have their own collections of methods and instance variables and so on. And if you followed up in homework 2 when I told you to go read about the datetime object, you now know that docs.python.org is sort of the mother lode of information about these libraries. So the datetime library is thoroughly documented. The tkinter library will have similar documentation. So all of these things are available to you. You should just bookmark that website. That's what I do. All right, now, because we're going to group a couple of elements together to make a larger whole, and the elements here are all buttons for us, 20 buttons, we're going to use a containing frame. So I'm going to create a frame here. This is an object of type frame. This object comes from the tkinter class, the tkinter library or module, which has a bunch of different class types in it. I'm going to associate this frame. I'm going to store it in self.frame, which is an instance variable of the object of type BoggleTK. And then I'm going to associate with this frame a geometry manager that says, here's how you lay out those buttons. And I'm going to use this grid geometry manager, which is a very nice way of laying out square tables of things. Right? If you have an array of things that you want to set out in like a 2x2 array, which is exactly what we have, you can do it with the grid layout manager. So the layout manager, remember, is the thing that if I resize the window, it relays out, it decides where the buttons go, how they respond to window size. So next I create my 20 buttons. Nested loop, row and column. I'm going to add a new button in this frame. I'm going to tell it what the text is. The text of that button corresponds to the letter in self.board by row column uppercased. So if you recall in our not online, not interactive version, we just printed out uppercase grid of letters. Well, here I'm just setting up each button to have one of those letters as its text. And then the command is the callback function that gets called when I hit that button. And then I tell it where that button goes in the grid coordinates of the grid layout manager. It goes in row column. Now, look, nobody ever expects you to write this kind of code straight up, right? What you do is you find something similar and you modify it for your purposes. Unless you become a professional tkinter developer and the demand for those is actually very small, you're not going to know all these things. You look it up in the manual, you model the examples, and you make your code work that way. That's the thing to do. Now there is this funny business here, lambda x equals rc colon self_press.x. And I would like to, for the moment, just ignore it. But I will tell you briefly what it is. It's coming up in one of our lectures. This is a lambda function. A lambda function in Python, like in many other languages, is what's called an anonymous function. It's a function without a name. Now, it seems like a weird thing to have a function that has no name. But functions without names are really useful. When you pass something around that has to be done, something maybe as an argument, a function that you want to call, and you pass it into a function as an argument, you don't really need the definition of that function so it be called by anybody else. You just want to pass the function and have it called in that one place and never again by no one else. When that happens, having a lambda function is actually a pretty good idea. And what this lambda here introduces says, look, I have a function that takes row and column as row and column as input arguments. These are the buttons, so it gives you row and column in the grid, and it invokes the press method. So this function is just a pass-through. Now we'll learn all about the syntax of lambda, which is a little obtuse and a little weird, but let's not do that just now. So just for now, just accept this is an anonymous function invocation. I'm going to pass this function without giving it a def and without giving it a name. I'm going to define it on the fly. I'm going to use it once, and then it's going to disappear. Same thing here. I'm going to have now 4 buttons across the bottom, which correspond to colon, plus, dot, and asterisk. And I, again, use an anonymous function by fixing row at 4, which calls self.press x. And I'm going to place all of these in the columns of row 4. Remember, 0, 1, 2, 3 are the puzzle, and 4 is the other. So the 20 buttons all invoke the same callback function, which pass row and column indices, which come from the event, from the mouse event, through this little lambda function that we just defined. So finally, I'm ready. I've set up my window. I've given it a frame. I've added the widgets. I've told the window how to lay out the widgets in a grid. I've invoked callback. I've associated callback functions through these lambda expressions to every button. And now I'm ready to go into busy wait loop, which basically is an invocation of the main loop method. That's it. So now my puzzle stops, and it waits for me to do something. And in fact, all of this is really all it takes. So the boggle round method that we had, which was very long, is all replaced with just these like 20 lines of code. And that's because most of the action in this occurs in this press method. Because if you think about it, every time I click a button, it's going to invoke the press method through the lambda function and give me a row column. And the button has to do something different depending on which button it was that you pressed. So you can already imagine what this press method looks like. This press method, which is the event handler, is going to look at which row column you just pressed on, and then it's going to do an appropriate thing for that row column. And incidentally, here, once you invoke this, the read-eval print loop doesn't respond. Only the tkinter events will run. And so you need to make sure that at least one of your press elements exits the busy wait loop. And for us, I believe it's the dot that stops playing. So let's take a look at the event handler. It sort of looks like this. It's just the method of the class boggle tk. It takes a location, which we know is row, comma, column. It's a tuple. And it's just a big if-else-if structure that basically handles 40, 41, 42, and 43, which are semicolon, plus, period, and asterisk, as special cases, and then otherwise handles all the other 16 buttons, which are just row column coordinates for the puzzle, in exactly the same way. So my job is to fill out this event handler to do the right thing for each of these 20 key presses, where 16 of these key presses do exactly the same thing, parameterized by row column, and the other 4 all have special use. When you have a function like this, we generally say that the function dispatches on the argument. The argument here is location. And there are other Python constructs like cases and so on that can be used to do something like this. I used if and else if because that's what we're used to. There are other constructs you can use as well. So let's take a look at at how we started implementing this. The first one, the colon, remember, is what I press to see which words I've already found. And as you recall, when we played the game in tkinter the other day, when I clicked on that, it popped up a window and says, words found, and it listed the words that I found. And to do that, I'm going to use a method here. This is a method called showInfo, which is part of the TK library, which takes a title and a body, and that pops up a window that says, inside it, these strings will get printed. And the strings are however many words I found, so 47 words, and then the format here is all the words joined together with a carriage return in them. So for all the words in my list here, I'm going to sort them out. I'm going to join them together with a new line so that they appear on individual lines, and I'm just going to print that out. All right, so if you find no words, you say words found, and it comes up empty, 0 words found. If you find 3 words, it says 3 words found, and it shows you the list of 3 words. Now, the plus and dot require exiting the original busy wait loop. You recall that plus says, give me a new game, and dot says, I'm done. So exiting the loop can really be done by destroying that root window. So you can just say, kill the window somehow, and that will exit the loop because the window's not there. But that's kind of abrupt and not really it's not really good practice. What we'd like to do is we'd like the window to exit gracefully. And for the window to exit gracefully, I need to use a method of that window to say exit gracefully rather than killing the window. So here's what I've done. If I click on the button at 4.2, and I forget which one this is. I think this is the dot. So 4.2 must be the dot. I'm going to pop up one of these little windows that says done and shows me the words I found. And I'm going to set this instance variable of type, this instance variable of the window, of the object BoggleTK to false. Remember when we defined the class, it had one new instance variable, which is called keep playing and defaulted to true. Set that to false, and then I'm going to set self-window.destroy. And this then allows me to sort of recover and return a value. Oops. I think that's all the slides I have that I need to cover for BoggleTK. So let's go take a look at the implementation. This is our next topic, so we'll not do that until Monday. Let's go take a look at the solution to Boggle. I need to open this way. Sorry, it doesn't know where I am, so let's close those. Let's see where I am. I am in. Oh, come on. That's odd. Let's just open it from the memory stick. All right, so we've seen there's that variable I told you about, the keep playing variable. We talked the other day about how we invoke, when I initialize an element of object of type BoggleTK, I add this variable, and then I also execute the Boggle classes init variable, init method by calling superinit. This is our play, which we've seen before. While we still have that keep playing variable set, then we're going to prepare a new game. We're going to solve it, and at the end of solve, we're going to actually enter the busy wait loop, and we're going to keep doing this until we're done and self keep playing is false, and we'll exit. What happens in here is that I create the window, and when I'm done with this game, I exit because I destroy that window, create the new game, go around and create a new window. So every new round, I'm going to create a new window. Yes? Yes. Both inits? Yes. In this, so when you create an object of type BoggleTK, this is the init function that's called. Not the one that's inherited. It's not called unless you explicitly tell it to, which is what this does. So this super function tells me who the inherited object is. It's like saying Boggle. And then I am explicitly invoke their init function. So in Python, as opposed to some other object-oriented languages, when you create an object that inherits, only the initialization of that inheriting object is done automatically. In other languages, you get the hierarchy, right? But not here. You just get that. If you want the hierarchy, you got to ask for it. Okay? It is a difference from other languages. Yes?
And the super is really only used if you're invoking the higher version of the method.
Yeah, it goes right up the list. All right, so that's our play object. The round we've already seen. You see that when I started with the simple stuff, everything else I showed you, right, was contributed to the round. Initialized the words found, initialized the path under construction, and then entered the loop. And then here is my key press all worked out with the dispatching on location. We've seen some of these. We've seen this one. We've seen these. The only really interesting one is oh, come on. I guess I'm not seeing all that window. The kind of interesting one is what happens down here. It's 4243. Here we go. The else. I'm simply going to. Here we go. This is the else that corresponds to a button that is not explicitly mentioned. I simply append its location to the path, and then I disable the button so that it can't be invoked again. That way we only have one of these run at a time. So if we run this, and I sort of see why this thing is breaking now, but let's run it and we'll see what it does. Yeah, it's over here and I can't move it. Let's see. If I move this over here, will the window pop up there? No, great, it doesn't. Oh, bollocks. All right, here's what we're going to do. Okay, you can see this little window up here. You can see it's the geometry is wrong because the default geometry is not what we expected. Here's my Boggle puzzle laid out. There are the 4 puzzles. So this is 0, 0, 0, 1, 0, 2. This is 4, 0, 4, 1, 4, 2. If I hit plus, that says give me a new game. I get the little info pop-up saying I found 0 of 29 words. It pops it up again. This is a new puzzle. So let's see if we can find a word here. Does my cheat sheet tell me what words are? Maybe not. Anyway, you get the idea. If I just start working on a path here, this is a nonsense path. I'm going to hit the asterisk, which shows up red because this is not a legal word. So I can go on and take my next path. Like this, and again it's red. If I could find a word that was legal, we would see that this would light up green when it was an actual word. If I asked the words that I've seen so far, I found no words, and you can get the idea. All right, and then period will end the game. Last 7 words, and we're out. Okay? So does everybody sort of see how this works? It's not particularly clean. There's work to do. If I get the chance after the wedding, I'll revise the code to make sure it works in 3.9 and make it available to you. Until then, if I remember, I will run the lab again tonight. Would you send me in the back a note tonight about Lab 10? Would you send me a note about Lab 10 so I can remember to rerun it? Yes? And I'll also post the Boggle code for you to play with. All right. Have a good test on Friday. Good luck. We'll see you Monday.